Hello everyone, I'm sorry I had to be gone today, but I'm at a teaching conference actually on the East Coast. And so today what we're going to do is take what we worked on yesterday just one step further. So if anything, most of what we're going to be working on today is about 80% review of what we worked on yesterday, and then about 20% of a concept that we actually used last chapter. So to start though, if you would please, have out your homework from yesterday. What I'm going to do is just read off what the answers were, and so you have a chance to correct it and then be ready to ask questions when I'm back. So if you would have out your homework, which was from section 7.6, it was in the book. If we need to pause it and wait till everyone has their homework out from yesterday, go ahead and feel free to do so. Otherwise, I'm going to read off the answers. So question number 3. That one, all you had to do was factor out a 3 from everything, and then it was factorable. So it was 3 times the quantity x minus 1 times x plus 2. Question number 9, you divide out a 3, and then the answer was h plus 2/3 times the quantity h plus 3. If you distributed this 3 right here to the first expression, then it would be 3h plus 2 times h plus 3. We talked about you don't need to do that. You just might want to do it though if you want to check your answers with the back of the book. Question number 11 would have been a 6 times the quantity x minus a half times the quantity x minus a third. To get rid of the halves, the book distributed a 2. To just get rid of the thirds, the book distributed a 3, and the reason they can do that is because 6 is 2 times 3. That's how they broke that one up. Question number 13, we would have written it as 3 times the quantity n minus a third times the quantity n plus 2. Again, the order of these doesn't matter. It could have been 3 times the quantity n plus 2 times the quantity n minus 3. Just to simplify, the book distributed the 3 to this n minus 1/3 to get rid of the third. Number 17, we would have written it as negative 1/3 times the quantity t minus 2/3 times the quantity t minus 3. And those were the 5 problems that were worked on yesterday. So mark any you missed, circle any ones you'd like to ask a question about so that we can go over it when I'm back. Otherwise, at the bottom of that homework assignment, I would like you to try the following warm-up question. It's a good review, items that we've been studying. Right now we're studying quadratics, but in the past we studied linear expressions, lines, and we studied exponential expressions, exponent equations. And so if you would please, at the bottom of your homework, I have 2 tables here. I want you to try to figure out the pattern that's going on and see if you can recall how we wrote equations for these 2 things. So take about, 30 seconds, pause the video, and come back after 30 seconds. Okay, let's go over the first one. If you look at this guy right here, the pattern down below is multiply by 3. Multiply by 3, and it does that every single time for y, and because it's repeated multiplication, we use exponents for that. So we would have said y is equal to, and then we need to know what the y value starts at, and the y value that we start at is the y-intercept, and that's this guy right here. So we'd say y is equal to 27, and the pattern is multiply by 3 repeatedly, so we put x in our exponent. Down below, the pattern is not repeated multiplication, it's instead adding 6 every time. Add 6, add 6, add 6, that's what makes a line. We can see the y-intercept starts out at 15, so we would say y is 15 to start, and we are adding 6 for every x, and that's what made that be a line. We would call the 6 the slope. So those are 2 things that we worked on in the past, and this chapter and the chapter before we've been studying quadratics. Okay, if you would please, how about your note packet? In the note packet it should say something like 7.6 day 2. What we're going to be working on is factoring the expressions that we were factoring yesterday, and now we're going to be solving them, so when they're equal to an equation, taking that last step and solving it. Here were our steps that we worked on from yesterday. Step 1 we talked about was factor out that leading coefficient, so we got back to expressions that we recognized where there was a 1 out front. And then what we did is we factored the rest by using the table and did not simplify our fractions until the very end. I want to show you one other way that you'll see this idea presented. It's actually more of a mental process, but we're going to talk through one example just because I think some of you could pick it up, and it's much quicker if you can do it. The problem is because it's all mental, you have to be able to balance quite a few numbers in your head at one time. But we're going to try it, just talk through one. So our goal is to factor this quadratic expression. Yesterday we would have divided the 3 out first and made thirds. I want to talk through one where maybe we don't do that. Instead of always using the table to solve these, a little number sense could help us reason through what two factors must be in some simpler cases. So what we're going to do is we're going to use the leading coefficient, which is this 3, and then the x squared, because that's the highest power. And then we're going to use the number constant term 2 to guide us. So what we're doing is we're kind of thinking through, we know it must factor to be this. If it multiplies to be 3x squared, the only way that would occur would be if this was a 3x and this was an x. That's the only way to multiply and get 3x squared. Now, we know that this last term is 2, and that comes from the multiplication of this piece and that piece. So the question is, well, what two numbers multiply to be 2? And I only know two numbers. They're 1 and 2. The question is, where do each of them go? So what I'm going to do is I'm going to show you the incorrect choice first, and then show you what the correct choice would have looked like. So let's say I thought, oh, maybe the plus 2 goes here, and the plus 1 goes over here. If I guessed that, I'm going to use a table just to check my work here. You could also, FOIL double distribution. I know this has to be 3x and x, because we know 3x squared is right here, and we know down here is our 2, sorry. Okay, we guessed maybe it was 3x plus 2 and x plus 1, and that matches. I get 3x squared, I get 2, but now we just need to make sure we get the correct middle terms. And when I do that, x times 2 makes 2x, and 3x times 1 makes 3x, but if I notice 3x plus 2x makes 5x, and that's not what I had. I needed 7x. So I must have chosen the order of those incorrectly. So instead of it being 2 and 1, it must actually be a 1 here and a 2 here. Then I go back, I'm going to flip these. It must be 3x plus 1 and x plus 2. Now x times 1 is going to be x. 3x times 2 is 6x. And if I notice here, now I've got the correct amount of x's. I have 7x. So the correct factoring would be 3x plus 1 and x plus 2. That's a mental way that you can go through this process. It's much quicker when you get faster at it. The problem is a lot of that mental game, well, because it's a mental game, is done in your head. So it's harder for me to, exactly explain it. So that's why we came up with the technique we did yesterday. But if you want to go this route and you can feel strong in doing it, feel free to do so. Otherwise, for the rest of us, we're going to practice doing it like we did yesterday. And so before jumping into the new little piece that we're adding for today, I want to recall an idea that we did last chapter. Last chapter, when we had quadratic equations where one side was equal to 0, how did we solve them? Well, instead of just plugging in random x's and hoping one of them would make the right side equal 0, what we did is we factored. We found two numbers that multiplied to be 12 and added up to be 7, and those two numbers are 4 and 3. So I write x plus 3, x plus 4. The order doesn't matter. Commutative property of multiplication, 1 times 2 is the same as 2 times 1. Now I have, let's do blue piece times red piece equals 0. One of them has to be 0, so in order for this one to be 0, it'd have to be x equals -3. So there's one of my answers. And in order for this other one to be 0, x would have to be a -4, and I've solved it. So what we're going to put together today is, if we can factor, it makes solving these equations where one side equals 0 very easy. And the reason that we care about finding when the right side equals 0 is because we know it helps us when graphing. Down the road, it's going to be again where our x-intercepts occur, just like they did last chapter. So really, we were putting together some old knowledge and some new knowledge. So what we're going to do is use what we did yesterday to solve when an equation equals 0. So I look at this guy, and I have a leading coefficient out front. It's a -1, and so what I'm going to do is divide everything by a -1. And yesterday we used fractions because it would have developed fractions. But if I look, every single one of these numbers is going to be divisible by a -1, so I don't need to use fractions because it evenly divides out. So I simply just get then a -1, and what's left behind? Well, it's an x squared minus 1x minus 20, because when I divide by a negative, it changes my signs. And again, I don't need to use fractions in this one because it evenly divided out. We'll need to use fractions in the next one. So I divide out a negative 1. Now all I need to do is factor the inside the parenthesis part. So inside the parentheses, I know I have an x squared, and I know I have minus 20 ones down here. So the question is, what two numbers can I find that are going to multiply to be a negative 20 and add up to be a negative 1? And I think about it, and 10 and 2 are too far apart, but 5 and 4 are only 1 apart, so that's going to work. So how about minus 5x and plus 4x? That'll do the job. So my factors have to be negative 1 times x minus 5 times x plus 4 equals 0. Then I go down the line. This negative 1 will never be 0, but this could be if x equaled 5. So there's one of my answers. And here's my other one. Would be if x equaled negative 4. We have two answers because we're studying quadratics, and quadratics' highest power is a 2. Second one. So this is really going to tie together what we did yesterday and what we did in the prior chapter. So I have a 2 out front, and so I need to divide a 2 out from everything so I get back to a familiar situation. But if you realized 2 is not going to evenly divide all of these pieces, so I'm going to need to use some fractions in the table to help me keep everything organized. So I divide out a 2, and then I have x squared plus 1/2 x minus 3/2 equals 0. If I start to write these things out now, and now I just need to work with the parentheses, I know I have x squared, and I know I need two numbers that are going to add up to be 1/2 and multiply to be 3/2. But as we talked about yesterday, so let's put the halves in here first. I know I need to add up to be halves. I'm counting x's, so I'll put my x's here. But the problem is, when I add up halves, I still get halves, but if I multiply halves times halves down here, I'm going to get fourths. So I need to adjust this piece down here to be in terms of fourths. So this piece right here needs to be in terms of fourths. So how do I get negative 3/2 to be fourths? I need to multiply the top and bottom by 2 to make the correct adjustment. So I'm going to have 2 times the quantity x squared plus 1/2 x minus 6/4. Now I have correctly adjusted for it, so I can go over here and put this 6/4 there. Now since I've taken care of the denominators, I only need to worry about the numerator pieces. The denominators were taken care of by the table. So I simply need two numbers that add up to be 1/2, so I really just need to keep track of the 1. So two numbers that add up to be 1, multiply to be negative 6/4. I've already taken care of the fourths, so I just need two numbers that add up to be 1 and multiply to be negative 6. And those two numbers are going to be negative 3/2 and 2/2. Because if I look, negative 3 times 2 makes my 6. And 2 times my 2 makes my fourth, so it does the job. So my dimensions are x minus 3/2 and x plus 2/2. I write them out, and they are, like I said, 2x plus 3/2 and x plus 2/2 equals 0. Now is when I finally look to see if I can simplify anything. 3/2 doesn't simplify, but 2/2 simplifies. That simplifies to be 1, so I could really write this as x plus 3/2 times x plus 1 equals 0. And now that I have it completely factored, it makes it really easy to answer the question. When will this thing equal 0? Well, 2 will never equal 0, but this would right here, the second piece, this would equal 0 if x equaled negative 3/2, or negative 1.5 if you wanted to work with decimals. So there's my first answer. And my second answer would be, this would be 0, making the whole thing be 0 because it's a long chain of multiplication if x equaled negative 1. And there's my two answers, negative 3/2 and negative 1. And then just like last chapter, those would represent my x-intercepts of my graphs, which we'll start to do later on in the following days, but not today. We're just doing factoring and then solving. So I need to factor with my table using my fractions. Okay? I'm going to give you a chance now to try it. So if you would, please pull out your whiteboard, and let's pause the video for I would say 2 minutes here. Leave it pause for 2 minutes, give people 2 minutes to try. Use your note packet to guide you. This is one of the more challenging ideas that we've worked on all year. But if you take your time, stay organized, use your note packet from today and yesterday to guide you, I think you should be able to be successful with it. So pause the video now. When we come back, I'll go through it. So pause the video now, please. Okay, let's go through it. The first thing that we would do is we would divide out the 2. I'm going to write these with fractions actually over here. And so if I divide out the 2, I know I'm going to end up with halves in the middle, and halves here, and as we talked about yesterday, halves times halves makes fourths. So I don't need to write this as negative 35 halves. I'm going to write this as negative 70 fourths. And then my goal is to find 2 numbers that multiply to be negative 70 and add up to be negative 3, because I've already taken care of the halves and the halves, making fourths bit. So 2 numbers that multiply to be negative 70 and add up to be negative 3, I believe, are going to be probably negative 10 and positive 7. That'll do the job. If I look, negative 10 times 7 makes my negative 70. Halves times halves makes fourths. And if I add them together, it makes negative 3 halves. So my factors, and this side was always equal to 0 on the right, would have been 2x plus 7 halves. The order of these, I guess it doesn't matter. X minus 10 halves, but instead of writing 10 halves here, I know 10 divided by 2 is going to make 5, so I'm just going to write 5 right now. Equals 0. And now I have it factored, I can answer the question. When would this part be 0? Well, if x equaled negative 7 halves. If you wanted to work with decimals, that'd be negative 3.5. Over here, x would be 0, or the whole thing would be 0 if this piece was 0 at the end, which would occur when x equaled 5. So there we go. Your 2 answers are negative 3.5, negative 7 halves, or x equals 5 would work. Okay. Awesome. That's the key idea for today. Last part that we're going to do is just look at a couple situations where people might have incorrectly used some steps wrong. So if you look at this one right here, the first thing that the person does in factoring is divides out an x, and that's a fair step, but the problem they do next is they say, okay, I have this piece, maybe I've underlined in blue, times this piece in red equals 4, and the only way I could multiply those 2 pieces and make it equal 4, they say, would be if one of them was 4, but that's not true. The only way that this trick works is if this side is equal to 0. You need one side equal to 0, because there's a lot of numbers that multiply to be 4 that don't include where one of them was 4. You know, instead of it being 1 and 4, maybe they were 2 and 2, or they could have been 16 and a fourth. So the problem here was you can only say that when I multiply 2 pieces and it equals a number, that one of those pieces has to be this number on the far right if it equals to 0. So the problem was they didn't have one side equal to 0. Okie doke. The second one I'm actually going to hold off on for right now, and we'll talk about the error when I get back. So for today, I just wanted to focus on this one. You need one side equal to 0 in order for this factoring technique to be beneficial. And with that, that's it. Like I said, today was mostly a review, going over what we worked on yesterday and just adding that one step of once we have it factored, because yesterday we were working on just getting to, you know, this step right here, and when we stopped. Today we're just taking this last step of once I have it factored, actually solving the equation, because I have an equation. Okie doke. So your homework today is actually in your worksheet packet that we passed out the first day we started this chapter. It should be in the worksheet packet, and it's titled like 7.6 worksheet, and it looks like this. If you want to, you could leave the video paused with the answers up here as you work, so you know if you're doing it right. But like I said, there is absolutely no way you can get these answers without showing your work. So I need to see your steps where you factored everything, you showed your table, factoring using fractions. when I get back. So if you want to, you can leave the video paused up here so you can check your answers as you work. Otherwise, have a good day, and I will see you when I get back. Thank you.